Well, well, what has the cat dragged in today? It's a basic tutorial on Unity. In this video, we're continuing on our look at our simple little space game. And the focus for today's video is going to be getting our character controller in place. Well, actually getting the everything in place when it comes to the code controlling this simple little game. Now, quick couple of caveats right at the start here. I am not going to be covering basic C# syntax in this video. That is a topic for a completely separate video. Now, if you know absolutely nothing about C#, don't panic, you can still follow along. As I'm typing things in, make sure you are pausing the videos and taking a moment to make sure that what you have typed in matches exactly what I have typed in. Don't try to get creative with variable names or anything. Make everything match exactly. Pay special attention to the curly braces and the semicolons because those tend to be the things that trip up new programmers the most when it comes to C#. Now, before we actually dig into the code, there are a couple of things that we need to take a look at. One is movement. How am I going to control my little spaceship right here? How am I going to know when a key was pressed or the mouse was used? We're just going to use the keyboard, by the way, but knowing all of these various inputs is a very important part of game creation. Now, a window that I tend to leave up almost constantly is the project preferences window, or project settings, I should say. So we go to Edit on the menu bar and project settings. The reason why this is found here instead of over on window is a legacy issue. This is where project settings was found many versions ago, but it has since mutated quite a bit. So edit and project settings, and that's going to pop open this little window right here, which I tend to dock in the same area as scene in game. Now, there's a lot of stuff in here. These are all of the different settings that can be relevant towards a project. Many of these you will never need to touch. Some of them you will mess with quite frequently. The one in particular that we want to take a look at is the input manager. Now, a quick note, Unity does have a new input system. The input manager is sort of the older input system. It works just fine, and I would strongly, very strongly recommend people who are new to Unity remaining with the input manager and not the input system. Because yes, that's what they're named, and yes, it's very confusing to keep track of. So, stay with the default, is what I'm saying, when you're new to Unity. The new input system is very powerful, but takes a lot more mental energy to learn. Okay, now, how the input manager, the default system, works is we have a variety of axes predefined for us. Now, we don't have to keep these, but we are for this video. The two that are of importance to us is this horizontal axis and this vertical axis. And as you can see, it already has 4 keys defined. Left and right for negative and positive, and A and D for an alternative negative and positive. Meaning, if I am holding down the left arrow or the A key, the value of this axis will be -1. If I'm holding down right or the D key, the value will be 1. And if I'm holding down no key or both at the same time, the value will be 0. That's how the axes work, at least when it comes to a keyboard. Same thing for vertical. It is bound to the up and down arrow keys and the S and W keys. So you can use WASD by default to tap into the horizontal and vertical axes, which is what we are going to do. Now, the names of these axes are strings. That means when we go to use them, we have to make sure that the name matches perfectly down to the capitalization. So when we go to reference the horizontal axes, we need to make sure it's capital H horizontal and capital V vertical. The other thing that we need to do before we move on to actually writing code is we need to take a moment to think about how are the collisions actually going to be registered. And for that, I'm going to briefly bring up, and we'll come back to it once we get to that part of the code, a very, very important page in the Unity documentation. Now, anytime you're looking at Unity documentation, make sure you check this version number here. Google searches are a bit chaotic in terms of which version of the Unity documentation they will take you to. So always make sure that this version number matches the version of Unity that you are currently using. And there's a lot of words here, and I would strongly recommend that you go through and read all of the words. But the really important part is down here in the bottom, and that is the collision action matrix. Currently, everything in our scene are static colliders. That means that I clicked on the wrong one. Yes, you can just reload. Thank you very much. There we go. That's the right window. If I select an object, there is a collider on it, but nothing else. So if I have a collider, but no rigid body, it is considered a static collider. Our little ship parts are the same way. There is a collider, but nothing else. Therefore, it is a static collider. And if we look over here, a static collider touching a static collider doesn't generate a message. What we need to do is we need to put a rigid body somewhere in our scene. And of course, the one that we're going to put this on is the spaceship. If you have an object in Unity that you intend to move, Unity really wants you to have a rigid body component on it. I mean, like, really wants you to have a rigid body component on it. So that is what we will do. Now, on our ship here, what you would not do is you would not put a rigid body on each individual part. Rather, you would take the top-level game object and put the rigid body there. So I'm going to add component. And I'm going to add a rigid body. Not a rigid body 2D. That's for the 2D system. We're working in 3D right now. I want a rigid body. Now, there's a couple of settings here that we're going to want to change. Setting number one, that's very critical to change, is we want to turn off gravity. Otherwise, if we don't turn off gravity, let me make sure that I have my okay, game view is correct. If we don't turn off gravity and we leave gravity enabled, yeah, our ship just kind of falls away into the void. So obviously that's not what we want. So I'm going to turn that off. Another thing that I am going to turn off is I'm going to freeze all of my rotations. Now, this is me probably being a little bit overly paranoid, but I don't want the physics system rotating my object. So I'm going to freeze out all of my rotations here. And again, that was found by taking my constraints and expanding it. Remember, anytime you see these little arrows, that indicates something that can collapse or expand. And I just checked all of my axes for freezing the rotation. Now we're finally ready to create the script. So since I want to keep everything nice, neat, and organized, I am going to go into scripts. I am going to, sorry, forgot to narrate there. I'm going to right click, or you could also use the assets menu. I'm going to go to create, and I'm going to go to C# script. And it should be automatically in rename mode, and I shall call this ship controller. Then I'm going to double click on it to open it up. Now, I already have Visual Studio open. So this will open up, in theory, a bit quicker than it typically would. Or it's just going to spaz out and open new copy of Visual Studio underneath. Okay, there we go. That was strange. Sometimes computers just do weird things to you. But in the end, get Visual Studio open. Definitely pause the video here until you have Visual Studio open and you are looking at this screen. Good to go? Awesome. One thing you want to double check, because again, this is one of those really weird points in Unity that's not actually a C# thing. So if you've learned C# prior to this, you might not be looking for this. You need to make sure that your class name and your file name match perfectly. The most common source of this error cropping up is when you go to create your script, and don't do the sequence of actions, by the way, I am just demonstrating. When you go to create your script, you accidentally hit the enter key, go, oh no, I didn't want new behavior script. I wanted to call this some awesome script. And now if I go to try to add the script onto a game object, it won't let me. Why? Because if I look at this throwaway file, which I will be deleting momentarily, my file name says some awesome script, but my class name says new behavior script. Wrong. No can do. These must match. So if you're ever in a situation where a script is suddenly not able to be found, like it's already been added to a game object and the game object is suddenly saying, I don't know where the script is, or if you can't add a component to a game object, check to make sure that the file name or class name hasn't been changed. Okay, and I'm going to immediately get rid of that because I don't actually want that file. And I still have a second copy of Visual Studio open. Let me get rid of that. There we go. And the reason why, unlike a lot of other YouTube videos, why I leave in snafus like that is just sort of to stress the fact that, yeah, it's, hiccups happen in game development. Don't get stressed over them and just keep moving on. Sometimes computers are weird. Okay. So I have my script file, the file name matches my class name. I am ready to go. The two big message pumps that Unity has, the start and the update, are automatically populated for us. But if you go and look at the mono behavior document page, it will show you all of the different messages that something inheriting mono behavior can listen to. Now, in this particular example, we don't need anything from start. So I am going to highlight from line 11 to line 7. And then I am going to delete it. And then just because I want to keep things a little bit neat, I'm going to delete out So that way I just have one blank line between my curly brace and the rest of this. So now my void update is on line 9. Well, it is for the moment. It won't be for very long. Now, there is one variable that we have to decide on, and that is how fast should my ship move. Now, we could hard code that number into our code. That would be a very bad idea, because that means every time you wanted to tweak how fast your ship moves, you'd be over here in Unity, you would do a test. Oh, nope, that's not the right speed. Come back over here to the script, change every single spot where you reference the speed value, pray you don't miss one, save the file, go back to Unity, wait for Unity to recompile, and test it. No, that would be terrible. We don't want that. So instead, I am going to create a public variable, because if I want a class level variable to show up in the editor, we make it public. So I'm going to say public. What data type? Remember, variables are just holders of information, but I need to know what type of information it holds. Well, speed could potentially be a non-whole number, so I will use a float for a floating point number. And I will call this variable ship speed. And I will give it a default value of 5. And end the line with a semicolon. The extra space that I just put in there is not necessary. I just do that for visual aesthetics. Now, if I want to adjust the speed, I can just use the inspector and I don't have to come back to the code. All right, update. What do we want to do every frame? Well, first I need to figure out in which direction should I move the ship. And again, I'm going to need a variable to store this information as I calculate it. I'm not making this one a class variable because I don't care about seeing this in the inspector or changing it in the inspector, and it's recalculated every frame. So remember, when variables are inside a method, you do not say public. So I am going to declare a vector, because anytime, or specifically a vector 3, because anytime we're dealing with position, x, y, z, that is a vector. And I'm going to call this ship offset, because at the end of the day, that's what I'm going to be calculating. How much of an offset, where do I need, how much of a distance do I need to move this ship? And I am going to assign it the default value of 0. Now you notice I did not do anywhere near as much typing as the number of characters here would indicate. Using the autocomplete system is very important for maintaining your sanity when coding. And so, how I did that, again, to narrate it a little bit better, is I typed in V. It was already on the vector 3, so I can hit tab, dot, and actually 0 is already here as a highlighted suggestion, so I can hit tab, and there we go. That's a lot faster than trying to type everything in manually. Now, the first part of this is I need to grab my horizontal and my vertical axes. I'm going to grab these one at a time. Horizontal is going to be X. How do I know this? Well, if I go back here and I look at my screen and I grab my ship, well, this would be horizontal. And oh, hey, yep, I am grabbing the X widget to move the ship back and forth. So I am going to say ship offset dot x, because the dot operator is how we access our properties, is going to be equal to, now, I need to grab this from input. So anytime I'm trying to grab a key press, a button press, the mouse, that is under the input class. So I'm going to do input with a capital I, dot, and what I need, conveniently enough, it's right here as my second suggested option, get access. So I'll hit tab to fill that in. This is a method, so I always have to have an open and close parentheses. Visual Studio will automatically put in the close parentheses for me. And as I mentioned when we were going over the input manager, all of those names are strings. So if I want to represent a string, I put in a double quote mark. And then I type in the name. Now, I could hit the arrow key to move over, but Visual Studio is actually smart enough that if I was to type in the quote and parens again, it knows not to double up on that. So I will typically type out those characters even though I don't really have to. And then finally, I end the line with a semicolon. Now I'm going to repeat the same thing for Y, only I'm going to get vertical instead. So ship offset tab dot Y equals inputs here, tab, arrow key down, tab, open parens, open quote mark, vertical quote paren, semicolon. So ship offset dot X equals input.getAccess horizontal, ship offset.y equals input.getAccess vertical. I would take a moment here just to verify that you don't have any red squiggles of doom. Like so. Always pay attention to the red squiggles of doom because that means the compiler is telling you, it's like, yo, you've got something very much wrong here. This makes no syntactical sense to me whatsoever. You always need to fix your red squiggles of doom. You just have to. So in this particular case, I have it because I just introduced a typo. Now the next part of calculating my offset is I know what direction that I'm going to be moving in, but I need to know how far I am going to move. Now, there is a step here that I probably should do, which I'm not going to do because I'm going to leave that discussion for a later date. And that is I should probably normalize right here. But I'm not going to do that, not for this one. We'll talk about normalization in a future video. Just wanted to point that out in case someone has heard of that before and you're sitting there wondering, now why isn't he normalizing right here? It's a conscious choice not to. We will discuss normalization of vectors and such in a later video. So what I'm going to do now is I've got my direction, but I need to completely type everything wrong. What I need to do is I need to multiply this. So I'm going to say ship offset is equal to ship offset times ship speed. But I can't stop here. If I stopped here, what I would be doing is I would be moving 5 units per frame, because this is called every frame. This would be a horrible idea because now my movement is dependent on frame rate. So someone who runs the game at 30 frames per second would move half as fast as someone who runs the game at 60 frames per second. That would not be good. So what we also have to do is we have to scale this. And what we have to scale this by is something in the time class, capital T time dot delta time. Get used to this, time dot delta time. You are going to be typing that in a whole heck of a lot, because this is how we scale something to be per second rather than per frame. So by multiplying our ship speed by time.delta time, we are saying basically that this 5 now is 5 units per second. Now it doesn't matter if someone's running this game 30, 60, 144, 15 frames per second. Doesn't matter. We've scaled by time.delta time, which is the fraction of a second since we've last updated. And we're good to go. Now that I have my offset, I need to actually add it in to my position to move the ship. Anytime we're dealing with anything involving position, rotation, scale, all of that is under the transform property. Now you have to be careful in dealing with transform. There is a capital T transform, which is the class, and there is a lowercase t transform, which is a property that monobehavior has. In this instance, we want the lowercase t transform. Hit the tab there to fill it in. And what we are going to want to manipulate is the position. So we're going to say transform.position is equal to transform.position plus ship offset. So I'm saying take the current value of my position, which is a vector 3, add this vector 3 to it, and then store that result back into position. And assuming that we have everything typed in correctly, our ship is capable of moving. Let's go test that. Hop back over to Unity. Let it recompile. Hit the play button. And not move. One would think with as often as I have done this, I would not always forget to do one step. Now, again, this is why I do these things in one take. What is the step that I missed? It's a very stupid, very obvious step, and you are probably thinking it as I was reaching for that run button. How is the code going to work if the code hasn't been added to the game object? It's always the little things, right? So I need to make sure that I've actually added my ship controller component to my player ship. Now I can hit the run button. And it sort of works. Only it seems that we're moving up and down instead of forward and backwards. And that's a very good lesson in why you have to pay very close attention to the axes. As we mentioned in a previous video, forward is on the Z. So you really, it's a little bit of a shift in thinking. Normally when we think of a plane, we're thinking in terms of X, Y, right? X is on the bottom, X is the horizontal, Y is the vertical. Standard graph from, high school math and such. But that's not how it's oriented in Unity. In Unity, the ground plane is the XZ plane. So Y is up and down. Very easy to fix. Hop back over to Visual Studio. And all we have to do on the ship offset right here, change that to a Z. So now it reads ship offset.x and ship offset.z. Save my code. You want to make sure that there's no little asterisks up here by your file name. That indicates that you have an unsaved change. So save my code, go back over to Unity, let it recompile, hit the run button. There we go. That is what I expect. Now we still have no collision information. I mean, it won't let us collide through. And it is doing a little bit of some wonky things to our ship's position. That will be fixed in the next video. This one's getting a little bit long in the tooth, so we are going to leave this here and deal with the collision information in the next video. And I'll end it with a shot of the code. This is sort of a final check for anyone who might need it. If you have enjoyed this video, or it has taught you a few new things, a thumbs up would be appreciated. And if you didn't think this was very good, well, give me a thumbs down so I know to do better for next time. Until the next video.